In this video, we're going to talk about for loops, and what you should already know is while loops, so please have already reviewed the video on while loops. So for loops are very similar to while loops. They are done a little bit differently, and they are done in fewer statements. So I have my Visual Studio instance up here, and I have my main program. A for loop, like I said, is similar to while loop. If we want to count from 1 to 100, similar to what we did in the while loop, and the syntax of the for loop is for int I equals 0. So where does the for loop start? Where the for loop ends, I less than 99, I plus plus. Remember that that's an incrementer. So I'm going from 0, 1, 2, 3, 4, all the way to 99. Let's put in our curly brace. So I've written my for loop and still need to write my body. But let's change my end value. I want to go from 0 to 99 to make sure I get 100 entries. Now I'm just going to do a simple printout of what the I value is. So in review, I have my loop and I have my body. I'm going to start at 0, go until I reach 100, print out the counter, loop back, increment the I value, and check it. A little bit different than the while statement. Let's run this and see what our results are. So as we can see, if I go back up to the top, I start at 0 and I go to 99. Let's compare that with the while statement. I have to set up my I value initially. I have my comparison in the while statement, and I have to remember to increment the I value. So now these two loops are semantically the same. They will do and output the same results. But if you'll notice, I have a red squiggly here. It says I is undefined, but I just defined it here. So why is it undefined? There's something called scope, and the scope says where a variable is alive or where it is active. When we define an I variable in the for loop, as we've done here, it is only available to us between these curly braces. So from here to here, that's when I is valid. Once the program reaches line 14, I, quote, goes out of scope, meaning it disappears. So I have to redeclare I. So I'm going to run this now just to show you that they both produce the same results. It appears only one loop executed. It can only mean one thing. I have a return statement at line 15. When I return back, meaning I go back to the operating system. At that point, this is not executed. I need to move this back at the bottom of the loop. But I still want to add a statement here that says I'm going to put an endl now the while loop. Endl. And I forgot my L right here. That's why I got a red squiggly. I will run. And now you can see the while loop produces the numbers from 0 to 99, and the for loop produces the numbers from 0 to 99. Since I'm on the topic of scope, if I have an x variable here, int x equals 5, and I have a variable called x in the while loop also, int x equals x plus POW, the power function, I, comma, 2. So I'm going to square I, add it to the x value. I'm going to print out the x value here also. And since my numbers are going to get large very fast, I'm only going to go to 10. Now I'm going to print out x again outside the loop. And what do you think the value of x is? So I set x to 5 here. We get in here. I'm redefining x in the while statement. So this x now hides this x on the outside of the while loop. So I'm creating a new variable. So I no longer can see x equals 5. This is a new variable, a new memory location. I execute the program 10 times, execute the loop 10 times, and I get to the bottom, and what do you think prints out? If you said 5, you are correct, because as soon as we leave this curly brace and go to line 25, this x goes out of scope, meaning it disappears. And this x reappears because its scope is between this curly brace and this curly brace. So let's see this run. And it says I have an error. Let's see what it says. The variable x is being used without being initialized. Let's set x equal to 1 here. It's saying I never initialized that. So now we'll set x equal to x times pow of I squared. X equals x plus I squared. Let's run the program and see. Okay, you can see x in the while loop is incrementing, but when we get outside the while loop, x is now 5. So that's scoping. Let's talk about the for loop again. So with our for loop, we can do some interesting things here. Let's set this to 1,000, and we don't always have to increment by 1. We can increment by 10. I plus equals 10. Remember, this is a shortcut to say I is I plus 10. So now I'm going from 0, 10, 20, 30, 40, 50. Let's run this. Okay, I'm incrementing by tens from 0 to 990. We don't have to increment. We could also decrement. So let's start at 1,000. And go to 0. Now we have to change our sign here because I less than 0 doesn't make sense. I must now be greater than 0. And let's decrement. I minus minus is decrementing. So now we're going from 1,000 to 0, and we're decrementing by 1. And you see if we're at 1 right now at the end, and we started at 1,000. So once we reached 0, we exited this for loop. So we've got the basic of for loops now. Now let's go back to that while loop we reviewed earlier. Remember we did a nested while loop? Let's create a semantic equivalent of that in a for loop. So I will do the same thing and set some constants. Remember we're creating a chessboard, which is 8 by 8. A for loop can be thought of as more simple than the while loop because it has less that you have to worry about. So we're going to go from I equals start I less than end increment I. Now we have an inner for loop, and we're going to call it j int j. Remember I said I, j, and k can be thought of as integers. Start j less than end j plus plus. Now I want to put my curly braces. And note, I do not have to increment I and j as I did with the while loops because they are handled for me automatically in a for loop. But I do want to change my output here, and I will do that right now. I'll just paste in cell I sub j created. So this is the same as a while loop we saw earlier. Okay, let me run this. So we start with cell 0, 0, which is row 0, column 0. We go from row, column 0, all the way to 7. Then we go from cell, row 1, column 0, all the way to 7, and so on until we get to cell 7, 7. This is the preferred method when we initialize two-dimensional arrays, and we will learn about that in an upcoming chapter, on chapter 5. So, simple, we have a nested for statement, and see that is indented. Let me show you the while statement here so you can compare it. Here's a while statement. Again, I'd have to int I equals start int j equals start. Now if we look at this, let me get this a little bigger so we can see everything. So the for statement on lines 13 through 19 are semantically the same as the while statement loops on lines 21 through 34. You can see the coding for the for statement is more compact than the while statement. This concludes the video on for loops.